All right, and I think I'm closing out on electrical noise and high voltage, and this one I'm particularly excited about because we're announcing a new product. So we're seeing an industry trend for higher voltage and faster switches. We're seeing up to, right now in automotive, 1200 volts, 800 volts is becoming quite common, but these silicon carbide switches are just snapping extremely fast. And we're starting to see GaN as well. So we're looking at the high voltage safety. Like from the human perspective and from the equipment perspective, this is terrifying. And we really, I put this picture up here. This is our equipment. This is at a customer. I mean, this is the kind of thing that's not uncommon. This is not a one-off. This is a lot of people. This is not just our equipment. This is how these labs look because there's so many cables. If one thing gets stripped or one thing gets cut, you've got 2,000 volts about to be a bomb. So high voltage safety we look at is really important. These silicon carbide and GaN switches are fast. The rise time is like nanoseconds. So what you end up with is a really high change in voltage in a short period of time. You have a high DVDT. Everything looks like a capacitor, which means everything carries a current. You're getting electrical noise everywhere. Every cable is an antenna. They're really hard to measure from an electrical noise perspective. And per my picture, cabling can get quite complex, and a lot of mistakes are made just because of cabling. So new powertrain demands are difficult to measure because of the cabling, because of the fast switches, and because of the high voltages. And a typical test setup ends up looking something like this, where we have copper cable coming into an instrument, current sensors, copper cable to a power supply, copper cable to the instrument, torque and speed coming over copper, and then things like temperatures coming over CAN bus. This requires long cables, copper connections, which couple noise. You can put the instrument close to the measurement unit, but is that always practical? So, what could be better? What could be better? Well, what if we had a box that did all the digitization sitting right next to the machine? What if we had high voltage modules that were completely floating, sitting next to the machine, digitizing, and then connected to the measurement equipment over a fiber optic cable? What if the current sensors plugged into that fiber optic box, or that completely isolated box got digitized and got sent back over fiber optic cable? This is the future that we're looking at. We're coming out with what we call our satellite modules. We have voltage satellite, which is 4 voltages, and a current satellite, which is 4 currents. And the goal is to shorten those cables to be, like 10 centimeters, as short as possible. So we have less distance to be coupling that high DVDT. We have less copper cable to make it confusing. 4 voltages come into voltage box, 1 cable back to the unit. 4 currents come into the current box, 1 cable back to the unit. Really try to shorten those measurement cables, bring everything back to one common cable. And then from the electrical safety, we don't have a copper cable coming back to a control room. We don't have a copper cable coming back to across the lab. That 2,000 volts is 10 centimeters. And then it's fiber optic. There's no copper connection. It's safe for people. It is safe for the equipment. Uncompromised safety. You are not putting people near high voltages. EMC issues will be minimized because of short cable lengths and everything being fiber optic and eliminating, extra copper cabling. High accuracy due to shorter cables and less reflections. That's the thing I didn't even touch on. There's gonna be reflections from these silicon carbide that makes life absolutely a nightmare from a measurement perspective. Shorten your cable length, you shorten your, I don't know if you remember your physics, you shorten that wavelength, you don't get that bounce. Integrated power supplies, and you can put these up to 500 meters away. You can just have these boxes sitting in rooms and flip cables around. So specs, I'm super excited about these, as I'm sure you can tell. I'm excited anyhow. This is extra exciting. Plus or minus 2,000 volts. We're getting ready for the future. Voltages are only going higher. Safety is only more important. Up to 20 megasamples per second. We really, for power, it's all in the fundamentals. So high switching frequency doesn't really matter, or high sampling rate doesn't really matter. But as current sensors get more mature, we start to need more and more for the powers. Fundamentals go higher. Also, if you want to look at your dead time, again, you get that scope functionality. You can start doing analysis with the high sample rate. For individually replaceable voltage channels, if you have an accident, blow one out. Nobody's going to get harmed. Swap that out. And they're also really, really good isolation. It's an incredible measurement from the differential standpoint. And we have all of the CAT ratings you could get. We have the 1500 volt DC rating. We have the 1000 volt Cat 3. It's really fantastic. Current satellite, more or less the same, except now we have a potential integrated power supply. With 6 ranges, power accuracy is going to be untouchable. 0.015% of reading plus 0.02% of range, and that is going to be real nice across the frequency spectrum. Same or better than our old equipment, but with all the safety and the high sample rates. Highest safety ratings, shortest cables, best signal integrity, industry-leading power accuracy. This is going to be the end-all solution for channel modules. And you can stack a bunch of these together. And in the future, we're also going to have temperature modules over fiber, torque and speed over fiber, NVH over fiber, to really just have a completely isolated system. This is going to be the be-all, end-all of measurement. I'm so excited. So in summary, eDrive testing, future-proof. We make a lot of measurements. We're coming out with things like fiber optics. We allow you to put in your own equations. You can bring in electric and mechanical. It's a really powerful system for understanding the system. Accurate and dynamic. We have really good accuracy. We are going to have even better accuracy in practice when you start looking at the noise immunity. And we allow you to do things like drive cycles. We make sensors, we make software, we make acquisition, and we have expertise. You can come to us, and we're one throat to choke, as a colleague of mine says. Auditable testing, we record everything if you want it, or you can throw it out. But we can record electric, mechanical, torque ripple, all in one location, all in one timestamp, in one data file for a very long period of time. You can store as long as you have hard drive space. So thank you. I think I've gone a little long. I'm very excited for your questions. I'm Mitch Marks. You can find me on LinkedIn here. And if you want more information on eDrive, you can find that with this QR code. Please just scan this with your phone. I'd like to thank everybody at Charge for having me. It is always a pleasure, and I look forward to speaking with you guys. Thank you for attending Motor Testing Bouillabaisse. I went through a lot.